Hello. Today I was checking some connectivity problems. For example, we have here this level connects with the following in this fashion, which is good. But the problem is that this exit here, if we solve for that exit, you will see the problem is that when we exit here, we will fall to infinity because these walls are part of this level and not of this one. So if we exit, we are in an infinite loop. So the problem, why it happens is easy to see. Is that obviously this place should not be connected with this corridor. This corridor connects this exit with this entry, and it should have a detour or something like that allows for this space to be part of this exit if it exists, or if it does not exist, it should be its own space to place a collectible or something like that. It should not be part of the exit here of this corridor. So what I was thinking of doing is to mark while we are generating levels in the world, mark as solid all the neighbors of the entry points. So, or the exit points, I should put, because, yeah. So let's do that. In the load level function, I think it's the correct point to do it. I should pass, let's see. Now, we should make it, after we generate the levels, we calculate the map bounds here. Okay, we set points solid for each wall in the levels, and we should do the same for the exit positions. Let me see. We have the exit. We have the sigils. Okay. We have the sigils. So for sigil sigil positions, this is let me see, it's an array of vector 3e, 3i, and they are local positions. Okay, so I wonder if we have we have the conway directions. Okay, so we need to calculate this vector in a similar way to this one. In vicinity, let's see, let's call it S for brevity. and to these coordinates we must add the conway vicinity. We need the okay, we have the back. Okay, let's see if we do this. Obviously, we will not be connecting anything because all the paths are impossible, because all these points are surrounded by marked positions. But we could, this is a bit, this is interesting. We should have a list of the added solid points to disconnect them. Yeah, okay. We should have for each level an array of, let's call it the moat. And an array of vector 2i, and let's see if not, if that vicinity point is not solid already, we set it and we append the vector. So when we are this moat will avoid unintended paths. But when we intend, you know what, we need to know, we need to know for each sigil. It's interesting. This should be a dictionary of lists. Yeah, because the we should, let me see, when we are using the sigils, the routes, we are using the pedestals. Okay. Okay, the pedestal could have this this moat. The pedestal itself could have this moat, and we should instead of using we should iterate over the pedestals and construct this and add the position to the pedestal. Now, this position will be global. I wonder if it will be a bit confusing, but no, because the moat is for use in the... Yeah, we should... Perhaps we should put the moat... This is a bit weird. Yeah, the moat should belong to the world, but let's do it like this for now, and I will later move the moat to the world. So when we are making the exit paths for each pedestal, we are trying to do this. If let's put an else here. First, we set solid point false. So we liberate the moat, and if we could draw the path, we do nothing, and if we couldn't make the path, the route, we reset the moat. I think this is tricky, because if we could do the connection, let's see first how this works. Okay, it could not make anything. Interesting. Why not? Set point solid disables or enables the specified point for pathfinding. All points are enabled for default. Okay. So the pedestal has the moat are global positions. Yeah. This is let's check again without doing this. This worked. Disconnected. Okay. Now, if we did the moat should be here. Let's mark, you know what? Let's mark let's duplicate the asset and let's do this so we can visualize what happened. Pedestal. Okay. Okay. This marked these ones. Interesting. This marked these ones. It's weird that the rotations. Okay, yeah, they are the neighbors. Then why this? Because yeah, it's the okay. Make exit paths. We should mark as false also the. Let's see. We are marking. Let me see again. If we want, in this case, we want to connect this with this point, we should unmark these coordinates, these two, and we should no, these ones, let me see, this is the beginning position. We unmark. What happened here? We are not trying to do anything, are we? Sorry. I'm using completely the wrong function. We are using the connect levels function. Okay. Okay. Now we are talking. Yeah. Before we connect the random paths, this function is no longer useful. So we should delete it later. So in this case, we should assert. This is called here. Okay. This is called here. And this is called here. Drop at level 1. We choose a pedestal at random. For that pedestal, we unmark okay, this is we are printing too many let's print again. Why we have so many? Do we have repetitions here? 26, 28, 1, 2, 3, 4, 5, 6, 7, 8. We have 8. This is weird. Let's see. Let's search. moat is point solid. We set the point solid. Okay. Yeah. We should do this after we mark, after we mark all the walls. Nice. Okay, now we connected this exit with this entry, and we did not occlude this exit like before. Now the problem here, yeah, this, let me see. If we don't do this like before, we obviously, here we have this problem, and here we have this other problem that are the same problem. And if we do this, we have this problem is mitigated because the distance in this case is enough. The distance of 1 is enough to put a wall, but in this case the distance is not enough. Okay, now to avoid this problem, let me remove the debug objects. In this case, we have this other problem here. Yeah, the thickness should be at least, let me think, we should have 1, yeah, at least 2, I think, to avoid this. Yeah, I think it should be at least too thick, the padding, the moats. Okay, so let's do something a bit weird. See, let's add a multiplier. And do all this 2 times. One to 1 distance and other to a distance of 2. Although obviously this, yeah, this is, let me show. You have the currently all the neighbors are these ones. If we have the pedestal here, the neighbors are these 8 dots. If we do this with the multiplier, if we do this in the multiplier, we will add dots here, 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 sorry, here, here, and here, and not here or here or here or here. But I trust that this should suffice, or we should make the correct mode instead of this. Yeah, Yeah, we should do it with another loop too wide, but let's try this first. Okay. Moat. Okay, let's add this debug symbols. Okay, we this was too much. Perhaps, yeah, because this blocks entirely the entry. In this case, it didn't block it because we are on. Yeah, now the problem is that we are blocking the exits. In this case, we are blocking the entries rather. We are blocking this entry here because yeah, so we cannot connect. Okay, I will need to think a bit about the implications of, yeah, let's, if we do the old one, let's think. Here the problem, we don't have a problem here. So here, for example, we could have blocked only, let's see, we could have blocked, why did we, we did put here a wall, we did not put a wall here, but it should be, yeah, it's interesting, like we should connect, because the problem are not the walls, the problem are the spaces, the walkable spaces. So if we block the neighbors, we calculate the route and then unblock the neighbors while putting walls, this should be blocked. So the moats don't need to exist in a persistent way, because we could construct all the moats yeah, on the fly. Yeah, interesting. Okay, I think I will stop here the video, but I think I have a nice solution. We remove the moats from the pedestals because they are useless now, and when we want to connect the levels, we only mark the moats of the level 2, of the level 1, and we make moats in the exit, in the entry of the in the exit of the level 2 and level 1 to avoid blocking. Perhaps in all nearby levels also that could be affected by a path, perhaps in all of them. We put the moats temporarily, we calculate the path, and then we remove the moats, and then we draw the path. So we calculate the path, we remove the moats, and then we add the walls. Yeah, I think I will do that. Okay. let me see. This in this state, yeah, we have errors. Okay, it's a nice cliffhanger to end on. Thanks for watching. Please share the video if you know people that enjoy or could learn from this kind of things. Thanks.